Try changing one letter of a Python string and the Python refuses. Strings cannot be modified after creation, and everything you've seen displayed in the shell so far isn't real program output. Today we cover two ideas: string immutability and the print function, your first tool for genuine output. Strings are immutable objects. Once created, they cannot be changed. Most of the types we've seen share this property. Suppose S is bound to the string car, and you want the first letter to be B, turning car into bar. The obvious move is to assign to a position. The element of S at index 0 is set to the string B. Python raises an error. Indexing lets you read a character, but never write one. No operation modifies a string in place. Every operation that seems to change a string leaves the original untouched. The workaround builds a brand new string with an expression, then bind a name to it. For example, set S to the string, B concatenated with the slice of S from index 1 onward. This constructs the new object bar. The original car still exists in memory. You've simply moved the binding from the old object to the new one. Later in the course, we'll meet mutable objects, which can be modified in place. Strings are not among them. Now output. The programs so far are static. They don't interact with anyone. It's tempting to think we've produced output because typing 3 plus 2 in the shell displays 5. That's not output. It's the shell peeking at the expression's value as a convenience. Put that same expression in a program file and run it. Python computes 5, silently discards it, and nothing appears. This is by design. If every intermediate expression printed itself, program output would be an unreadable mess. To communicate with a user, you state explicitly what to display. Explicit output comes from the print function. Wrap an expression in print, and Python displays that expression's value, and only that. Bind S to the string the. Then print the length of S and print the element of S at index -3. The first call evaluates the length, which is 3, and displays it. The second call evaluates the character at index -3. Counting from the right, -3 lands on the first character, T, so it displays T. Every print call ends with a new line, so consecutive prints stack vertically. Each result appears on its own line. To put several values on one line, pass them to a single print call separated by commas. Print the string D, the integer 3, and the string musketeers. Python prints each object regardless of its type. Strings and integers mix freely, and automatically inserts a single space between consecutive objects. The result reads the 3 musketeers with spaces between the words. Those spaces come from the commas, not from anything you typed inside the strings. One print call, multiple objects, one line of output, spaces handled for you. Sometimes you don't want those automatic spaces. You want exact control over spacing. The natural attempt is concatenation. Print the string, the +3, plus the string musketeers. This raises a type error. Concatenation with the plus operator only works between strings. Python sees a string on the left and an integer on the right, and refuses to glue them together. Commas accept any type because print converts each object for display. Plus is a string operation. It demands strings on both sides, and the integer doesn't qualify. The fix: cast every non-string value to a string first. Print the string the plus the result of converting 3 to a string plus the string musketeers. The str function builds the string 3 from the integer 3. Now all 3 pieces are strings. Concatenation succeeds, and the output is the 3 musketeers crammed together with no spaces at all. Because concatenation adds nothing, you decide exactly where spaces go by writing them into the strings yourself. Full control at the cost of explicit casting. 3 takeaways. First, strings are immutable. No operation changes one in place. You build a new object and rebind the name. Second, shell peeking is an output. Real programs display values only through print, and each call ends with a new line. Third, commas in print handle any type and insert spaces automatically, while concatenation demands strings, requiring star for everything else. Output is now under your control. Input comes next.